If you've ever been flying in an airplane and you look out the window and you see these big green circles in the middle of a field, what is that? Today we're gonna build the thing that makes this happen.
This is my buddy Trey. He's a farmer. Farmers are geniuses. We established that in the last video we did together about grain bins. Today I have a question. I want to know what these big things are that I see in the fields. What is that?
It's a center pivot irrigation system.
A center pivot irrigation system.
So it's a tool we use to transfer, in this case, groundwater out to the field and then use a circular pivot to apply it to the crops when they need it. If we don't get sufficient rain from Mother Nature, we can cut the pivots on and give the crop what it needs.
We're building two pivots, right?
That's right.
Okay, and one in that field and one in this field, and I'm basically just gonna do whatever Trey tells me to.
Sounds good.
Let's go get smarter every day and learn about irrigation pivots.
So I see these things while driving around all the time. They look like big bridges or cranes kind of on their side. Okay, this is our field, this is our dirt, and this is a pipe. We're gonna put water out in the field with a pipe. It's called an irrigation pivot, so we've got a pivot point here. We have to rotate the pipe around the pivot point. So there's tons of questions here. Like for example, when the pipe fills up with water, it's going to get heavy and it's gonna want to sag, right? So how do we support that pipe from below? And are there different sections to this thing, or is it just one long run of pipe? And what do the sprinklers look like? When crops are in the field, how does it move without damaging the crops? And how does this thing even move? All this stuff started to become clear to me once we went out there and started building the thing. The first thing that we did is we poured a pad for the pivot itself. After that, we spent a lot of time literally digging ditches so that we could run the pipe out to the pivot point. This was a family affair. Trey got the whole family involved. My job initially was to lube up the pipes and connect them together, as Trey's brother used the track hoe to dig the ditch, and Trey kept me supplied with new sections of pipe. We also ran wire all the way through the ditch beside the pipe all the way to the pivot point itself, which tells me that's where the power for the whole pivot comes from. The next big step came a few weeks later when a crew arrived led by a father-son team. You got Andy or Andreas and Jose. Jose is who I like to call the Jefe. These guys are experts at assembling irrigation pivots.
How many of these have you built? You.
Me?
Yeah.
Woo! Here in Alabama, maybe 400.
Wow, 400.
500.
Wow. ¿Es posible para ayuda? Can I help?
No.
No, you don't want me to help?
No.
Stay out of the way? So I've got to figure out how to establish myself as a trusted individual. You want me to do them? Three on each side? Yeah. ¿Dónde?
3 long and 3 short.
Okay, got it. 3 long, 3 short, each location. My first job. I think I'm in.
They grew more tolerant of me and started letting me do more stuff. So we laid out all the parts for what ended up being the first of 3 200-foot sections of the pivot. After laying all that stuff out, we started putting together this pyramid that would eventually be the center of the pivot.
Un momento. Listo. ¿Dónde? Faster when I get out of the way.
Next, we assembled an electronics box that would eventually run the whole pivot, and we attached that to the side of that pyramid. Jose then picked up the whole thing with a forklift and drove it over to the cement pad, where he put it down and bolted it to the concrete. Meanwhile, we jumped back over and started stringing together the large rods that would eventually support the whole pivot arm. These rods are in tension, and I thought it was really cool the way we clasped them together with these little bracket mechanisms.
All right, teach me what my next job is, Andy.
Yeah, it's got a gasket on each one. See, it's got a flat
Yeah.
inside. On the bottom,
Uh-huh.
it's different.
Okay, just make sure not to pinch it.
Yeah.
All the bolts on one side?
All both facing the same way.
Okay, that all the way down, right? So I've learned what happens is there's like one task you learn, and then you do it 100 times. That seems to be the way this works.
When we finished organizing the pipes, the tension rods, and the structural supports that holds it all together, we then unspooled electrical wire and attached it along the length of the pipe. We then started connecting these plastic tubes, which I'm pretty sure is how we're going to attach the sprinklers.
I was a little upset because these things are soft, right? And so they're cross-threading when you put them in the metal, which is difficult. But Jose was explaining to me that that's on purpose, because if there's a storm and this whole irrigation system flips over or something, these things will break off and you won't damage the pipe. So that's on purpose. Another thing that I'm observing here, this pipe has a little spigot in every hole This pipe does not. It's empty. It's got one there. It's empty. It's got one there. And so at this point, I'm starting to understand. I'm thinking as this arc sweeps around the field, the arm that's closest to the pivot center, this one's not going to move as much as those out there. So if you have the same flow rate in each location, you're going to water the inside of the field more than the outside of the field, and that's bad. Oh no, we have hoses. What does this mean? And these are the sprinkler heads. Oh, they've got numbers. So it feels like we're going towards this. There appears to be a weight on the nozzle. The sprinkler head. So that holds it down over the crop, I guess. I was wondering what those were. They're weights.
At this point, stuff started to get serious. Jose was on the forklift and he picked up one of the spans of the pivot, which I learned they call towers. We'd been hustling all day, but there was a definite increase in the expected pace coming from the bosses.
Are we?
Come on. Come on. Come on. Right there. Come on. Come on. Come on, guys. Come on.
How do you do it?
I couldn't get the bolts in because I didn't know what parts of the truss were in tension and what parts were in compression. Jose, of course, understood everything.
Man, that's a man that's done that a lot. So we're building trusses, and I am the inexperienced man on the job. This feels stressful. Boy, this is happening fast. The gloves are in the way. Coming in. Just a whole pile of them.
Once the tower started coming together, it was amazing to see how the pipe is an integrated part of the mechanics of the overall structure. So it does two things. It provides the water and it also provides structure.
I'm jealous of the aprons. Very jealous of the aprons.
At one point, I made a mistake and complained about the 90-degree heat.
Nice. It's not hot.
This is not hot?
Hell no.
The next big step was to attach the axle.
Hold it here. Come on. No. Watch it con los fingers. You know? Huh? Come on. Oh, yeah.
At this point, one of my big questions was answered. We attached the drivetrain and an electric motor that would turn the wheels, and next, of course, we had to attach the wheels themselves. Interestingly, there was a second set of temporary wheels, which we had to bang into some piping so that we could pull this thing across the field.
At the end here, so we gotta have the water flow from one section to the other. It's my understanding that this is gonna go up top, and this is going to be the interface between one section and the other. The next question though is, how do you keep one section of the pivot, if you're swinging around the field that way, how do you keep them lined up? So there's got to be limit switches in there somehow. I just don't know what those look like. So, I don't know. Look at him, he's about to pull this whole thing. We should probably get ready to walk.
Jose pulled the first completed tower section all the way across the field and had to do quite a bit of a dance to back it up perfectly so that the connection point was right where it needed to be so we could bolt it up.
That's it. Okay, it looks like the pipe is going to have to come up and over and then plumb straight up into this. Power is going to have to go through that box right there, the control box. These slip rings are fascinating to me. So these slip rings, you can see there's the brushes right there. Obviously I would not want to be touching that if it was electrified, but that is providing the power for the whole thing, man. And those are thick copper. All right, let's head down. 1 Corinthians 3:7. Trey had that put in.
So back to work. We had 2 more tower sections to build, which by now I kind of understood the process a little bit more, and I think I started to be helpful. I even got to wear one of those little aprons which carries the nuts and bolts, and I don't know if they were just being nice to me, but it made me really happy. Anyway, we got the wheels up and running on the second one, and then we took it over and attached it to the first.
It's literally coming together. I'm starting to understand it.
And then we got to build the third and final tower section, which had a wrinkle to it, which the first 2 sections didn't have.
Oh, it's the end. That goes on the end. All right. I was wondering what Jose was getting. He's getting the big spooty thing on the end.
So this being the outermost section at the end, it's essentially a large type sprinkler, you know what I'm trying to say. It shoots water way out beyond the end of the pivot. It's really fun to see the engineering involved in this little contraption. If you look, it goes to one side and then it cams over and it reverses direction, and it's all completely mechanical, and it's controlled by these little weights on the side.
So it goes, this is gonna hit that. throws the cam, throws this back.
When we came back the next day, I received what was the final blessing from my jefe. Forget the nail apron, he let me drive the forklift, which in my heart was the best gift that Jose could have ever given me. After everything was in position, Trey just needed to finish connecting all the electrical lines and then run the well pipe up through the center of the pivot point. And a few months later, I was able to come out and see how they actually performed in action.
So I haven't seen this thing operate yet. I spent a lot of times working on these things in your field. All right, here's the wheel. And the wheel makes its own little path here, right?
That's correct.
Knowing you, farmers aren't lazy, but farmers are technologically advanced. So I would assume that you have the ability to turn this on from your phone right now.
I do.
Okay, we haven't talked about this. Whoa, almost threw your phone. I want you to see the phone, so we're going down into the beans.
Okay, so this is how you set it.
That's correct.
So you're setting, it's in polar coordinates. So you're setting start 22 degrees, end 93 degrees, and that's cardinal directions, right?
That's right.
Okay. Zero's north, okay?
Right, and so,
You just uploaded that?
yep, and so, well,
Oh, I hear it.
What do I hear? Oh, it's moving.
See the water coming out of it?
No, I don't. Oh, it's coming towards us. So it's priming it.
It's priming it, and so,
So there's air right here, and there's water down there.
that's right.
Check out this view from the pivot point. You can actually see the pipes get heavier as they fill up with water.
It's coming towards us, and it's spraying a lot wider than I anticipated. That is a lot of flow, man. That is way more water than I thought. Can I run up the leg?
You can.
Oh man, golly.
Don't touch those boxes up there.
Don't touch the boxes, I will not. Dude. So those things spin.
Yep.
Do you like your pivot?
I do like it. Do you?
I do like it. This is, there's more to this than I thought. Look at all that.
There were two more big questions for me with this pivot. First, how do they distribute water evenly, since the sprinklers at the end of the pivot would be covering a lot more ground while it makes a circle than the ones near the center of the pivot? How do they take that into account? I had noticed earlier that they spaced out the sprinklers closer together as they got further out, and there were gaps up towards the center of the pivot. But was that all?
But basically each nozzle's got a regulator in it, a 10-pound regulator. The further you get from the center, the bigger the orifice is on the nozzle.
Up there, you have the same pressure, but the orifice is smaller. This plant needs to see the exact amount of water as that plant up there near the circle.
That's right.
Near the pivot, excuse me.
Near the center.
Yeah. And so the way they do that is by varying the flow rate on each of these.
That's right.
And that was why it was so important for each nozzle to be numbered and go in its correct place. They needed to be assembled in the correct order. The second big question is how exactly do the pivot sections stay in line with each other? And usually slow-mo footage is what I like to do to learn something new, but in this case, I had to speed it up to see what was happening. This is a camera placed back at the center of the pivot, and I'm looking down the whole length of the line. Now, I'm speeding it up, and can you see what's going on here? The sections don't seem to be moving continuously, do they? They're kind of walking. They're starting and stopping. So what's happening here?
We're on the second to last tower. So that tower down there is the last tower. That's the furthest point away from the pivot point. The pivot point is back up there. So we've got the box lid off here. We're not going to touch that because that's AC power, and that's a no-no. But if you look down here, you can see this bar right here on the left is connected to the far tower, okay? As the far tower moves in relation to the tower that I'm on, it adjusts this linkage right here. That linkage on that tower goes to this switch right here. and it's rotating that switch.
On the inside of the box, that arm is connected to this little black cam, which rotates. Depending on the angle of that cam, it turns these little brown limit switches on and off, which then starts the wheels driving this particular tower section. So this little cam is the magic. It's telling this tower section whether it needs to move or stop in order to keep up with the next tower down the line.
So what that means is that farthest tower is controlling the tower that we're on. And Trey, they're all controlled by the one further away from the pivot point, right?
That's correct.
Going back to this shot, you can see the entire control system at work. It's basically a game of follow the leader. The tower at the far end sets the pace, and everything in closer to the pivot follows suit with what engineers called bang bang controls. Each limit switch along the way tells the wheels when to turn on and off, and that ends up aligning it in what looks like to the naked eye a perfectly straight line, but it's not. It's a carefully choreographed control scheme, and I think it's awesome.
Before we get in this big combine and go try to harvest some beans and measure them, I want to tell you about one thing. So I've started doing this thing that I think is really cool. It's a little silly, but I love it, so I'm going to tell you about it anyway. Way back when I did the baseball cannon, I sent everybody that was a patron a baseball. Then I asked people to stick with me for a while and continue supporting on Patreon, and they did. And I did this thing, and I didn't tell anybody about it. I called it the Supersonic Baseball Team, which I love, and I sent everybody a sticker for sticking with me. And I know it sounds silly, but I just love it. So that was last year. I've done something different for this year. I have created what's called the Smarter Everyday James Webb Space Telescope Space Team. And this year the stickers are holographic. And here's what I'm trying to do. I just want to give people something to say thank you for sticking with me. You don't need this. You don't need this sticker. But let's face it, look at it. You kind of want it, right? I do. You don't need it. This is just a way of me saying thank you to everybody that supports Smarter Every Day on Patreon. I lost a big sponsor this year, which was a pretty big deal. You get what I'm going for here. You understand what I'm trying to do, and you're willing to pitch in. So I'm gonna create a new team every year. And the cool thing about it is they're kind of nostalgic. Like last year, we built the Supersonic Baseball Cannon. This year, my dad worked on the James Webb Space Telescope. We made videos about that. And I'm already working on what we're gonna do next year for the team. So the point is not the sticker. The point is to say thank you for those that have stuck with me on Patreon. And if you consider checking that out, it's always hard to ask this sort of thing, but if you consider supporting on Patreon, I'd be grateful. You can do that at patreon.com/smartereveryday. There is still time to join the team for this year's sticker. If you're sticking with me at the end of the year, I'm gonna send you this sticker. So anyway, thank you so much to those that support at patreon.com/smartereveryday. I'm truly grateful, and let's go get on this combine and see how many beans are in this field. Okay, we're harvesting beans here. You can see them over the shoulder. Trey is driving the combine here. This is the non-irrigated portion of the field, and our yield is around 60 bushels per acre, is that right?
That's right.
Okay, and so we are going into the outer arc. What do you call the part that sprays?
The end gun.
The end gun. So we're entering the irrigated portion of the end gun, and we'll see how our yield goes up. And so right now, this is irrigated beans now.
That's right.
Okay, all right, irrigated beans, what's our yield up here? We're mid-80s on the beans. So that's about a, what, 25% increase? So what does 25 more bushels per acre mean? That's a big deal, right?
That's a big deal, yeah.
How long would it take a pivot like this to pay itself off?
Based on the rainfall this year, on this return, this increase in yield, probably about 5 years would be the ROI on it.
And then after that, it's profit.
Right, but we had some corn that was irrigated this year that basically the irrigation system made a lot more money because of the way the weather fell with the rain.
So it's all about the weather.
It's all about the weather, yeah.
So farmers are economists, weather people,
Scientists.
You literally have a master's degree in hydrology. I know this about you. So this is mechanics, yeah. Farmers are geniuses, and this is why you got food on your plate today. So thank a farmer. So I hope you enjoyed learning everything about pivots with me. It was fun building it, laying the pipe that feeds the thing with water, learning about the wells, and then ultimately getting to see the beans that the pivot helped make. So hope you enjoyed this episode of Smarter Every Day. I'm Destin. Feel free to subscribe if you're into this sort of thing, and consider supporting on Patreon if you're interested in that. Farmers are geniuses. Go say thanks to a farmer. They feed us.
I'm Destin. You're getting smarter every day. Have a good one. Bye.